And hello everybody, Mr. Callen here to help you with lesson 8.10 called Couldn't Square Less. You're going to need your textbooks open, page 965. Let's not turn in our weekly review. We'll do the homework review and the turn in upon my return. All right, pause your video please. Page 981, take 1 to 2 minutes. Let's see if you can solve this. Note it says solve as many ways as you can, but let's see if you can solve it. Come on back when you're ready. All right. Couple things to point out here. We got 3 students that we're going to show your work to. First of all, we have Ahmed's, and this actually looks like a method that we learned before. The first thing Ahmed did was take his binomial and expand it from factored form into standard form. You might choose to use a box, x minus 1 times x minus 1. And he then decides to subtract 36 from both sides, getting something now in standard form equaling 0. Now we can use the zero product property to say, hey, let's go ahead and refactor this. In so doing, either one side is 0, add 7 to both sides, or the other factor is going to be the 0 part. Take away 5 from both sides, and you see 2 solutions. Now, what you might have missed is the fact that we can actually use the graphing calculator. Once upon a time, we would graph something that looked like this, and it made a lovely U-shaped parabola. But what's interesting is you can also graph y equals 36, and you could say, okay, so when is x minus 1 to the second power the same as 36? And, as you can see, they do in fact hit each other. Lo and behold, they hit each other right where x equals -5, got it, and where x equals 7, they would be the same values. So Binta's method is the graphing method, Ahmed's method is the factoring method. Charlie's method is what we just dipped into. Now Charlie says, okay, we get rid of add with subtract, we get rid of multiply, divide, we get rid of a second power with a second root, being fair to both sides. Of course, second powers and second roots cancel out, which leaves us with a single factor of x minus 1 equals, and oh yeah, we have to point out we have not one but 2 different possible numbers that if you multiplied by itself would be positive 36. And of course, those numbers would be positive 6 and negative 6. Now again, Charlie has not fully finished, so let's go ahead and add 1 to both sides, in which case his first solution, x equals 7. Let's add 1 to this second solution. Well, look at there. All of these have the same solutions. Ahmed using the factoring method, Binta using the graphing method, and Charlie using where we are heading next, taking the square root of both sides. Now, folks, we've already solved with factoring. We kind of solved with graphing quadratics. That's something that we might need a little more practice before the next test. But our focus today is going to be solving by taking the square root of each side, noting that there could be 2 possible solutions. Remembering, please, the square root of 9 is 3, square root of 49 is 7. Those top 3 are all nice, pretty, rational integers, but the square root of 6, not so pretty. Goes on forever, does not repeat. So if we're asking for exact solutions, don't write square root of 64 when you could write 8. Don't write square root of 49 when you could write 7. But do write square root of 60 instead of giving this number. P.S. Don't forget, it might be not 1, but 2 different solutions. Keep that in mind. All right, page 982, folks, page 982. I want you to take a look at Binta and Charlie's method here for a different equation. Here we have x plus 3 to the second power is equal to 25. Now, Binta uses the graphing method. Charlie does, in fact, use the square root of both sides. Sure wish that he would show his work. Now, pause for a second. I want you to ask yourself, where are the 2 solutions in each student strategy? Pause. Come on back when you're ready. So naturally, what I'm seeing with Bintas, I can see the solutions. I can see where the two relationships meet. In both cases, y would be 25 when x is negative 8, or y would be 25 when x is 2. I guess that kind of answers the bottom part where it says finish each student's work. So let's go ahead and just write that in. X is negative 8 or x is positive 2. Now, honestly, can't really see Charlie's solutions yet. When we're doing this, we're looking for two possible solutions, and we got to find where x equals. So let's go ahead and finish Charlie's work. Either x plus 3 is equal to the positive square root of 25, that'd be 5, or x plus 3 is equal to the opposite of the square root of 25, that'd be negative 5. In both cases, we can subtract, and to no one's surprise, we'll get the same solutions. Again, you see Binta's graphing, which we haven't talked too much about, and Charlie's taking the square root of both sides, remembering, please, that there are two possible quantities multiplied by itself that would get 25. That would be either positive 5 or negative 5, and we often use that plus minus symbol. All right, now I want you to take a look down here. One more equation for Charlie and Binta to duke it out with. X plus 4 in parentheses squared is equal to 40. We are asked to finish each student's work. Now, a lot of you are like, Mr. Cowan, let's go to Binta's work because it was so much easier. Uh-oh. Now, wait a second. I don't know about you guys, but I don't exactly know what the solutions are looking at Binta's. I mean, I can come up with, I guess I can guess, like, well, what are we going to guess? We're going to guess 2.3. We're going to guess 2.4. We're going to guess 2.375, blah, 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 blah. I'm really having a hard time finding the solutions with Binta's graphing method. Now let's look at Charlie's graphing, or Charlie's solving method. By taking the square root of both sides, a square power and a square root cancel out, leaving us with x plus 4 is equal to the square root of 40. Oh, and of course, we're going to see that plus or minus, aren't we? Now, if I went ahead and split this up into two possibilities, either x plus 4 equals the square root of 40, and unfortunately that is not a rational root, so we got to leave it as is, or x plus 4 is equal to the opposite of that. In both cases, we'll subtract 4. In both cases, plus 4 and minus 4 cancel out. However, here I'm going to go ahead and put the constant term, the negative 4, first, and then a positive. And over here, I'm going to put the negative 4 first and then a negative. Now remember, we sure like Binta's method, and it surely has some advantages, but I wonder if you could see some major disadvantages. If it does not hit perfectly at the integers, it's going to be really difficult to figure out using Binta's method what the heck is the solution or the solutions. However, Charlie's method, while it takes a little more work, Charlie's method is going to be exact every time. So, disadvantages of Charlie's method, it might take 2 more steps, 5 more seconds, maybe 10 or 15. But no matter what, you can always use Charlie's method to find the solution. Binta's method, afraid it didn't kind of help us with this bottom number 4. Now, what we're going to do right now is we're going to explore what Charlie's talking about here. I can solve any equation if I can get it to look like this. So our goal is to rewrite each equation so that it looks like that format. Now, we're trying to get some power equaling something. And inside I notice we have an x plus 3, but we also have that times 2. So how do we eliminate the times 2? Inverse of multiply is divide. As long as I'm fair to both sides, we maintain equivalency, and 20 divided by 2 is 10, and I think we're in business. All right, let's take a look at problem B. Again, we want it to look like something squared equals something. Inside the parentheses, we have the x minus 4, but outside we have this plus 12. Let's go ahead and eliminate that plus 12. And now we're in business again. Pause for just a second and listen as we go along. This one's going to be a little trickier because I surely want to get rid of that 6, but that 6 is a positive, ladies and gents. Now, look what that leaves me with. And before you start freaking out, Mr. Cowan, isn't this one of them that has no solution, Mr. Cowan? Pay attention, because we still have this negative symbol to get rid of. Now, I like to put a -1 there. And if we divide by a -1, -1 divided by -1 cancels out, leaving us with the square of x minus 5 is equaling +8, and that is something that we could find a solution to. And I didn't even notice over here, this one, I bet would have no solution. Now, I'm going to ask you to pause your video. If you really want, you can split up, you and your partner could do this, but I'm going to do partner A's with you. But I want you to get a jump start on that. Look at these problems. Look at 7, 8, 9. How are they similar to number 6? How are they different than number 6? Are they closer to A or B or C? And if you do split it up with your partner, you guys should have the same solutions. So pause your video, see how you do, and come on back when you're ready for me to walk you through it. All right, into number 7, where I think number 7 looks a little bit like part B, we have a +3 to get rid of. So I'm going to go ahead and I'm going to eliminate that -3 with a +3. That leaves me with the square of x minus 6 equaling 3. And now that that square is all by itself, we can get rid of it. The inverse of a second power is a second root. Some people don't write that too, but I like to. And I'm going to take the square root of 3 over here. Oh, and we need the plus or minus, don't we? Now a square power and a square root cancel out, leaving us with, I'm running out of space, folks, forgive my big writing, x minus 6 equals plus or minus. I can't help but notice that the square root of 3 is irrational, so I'm going to leave it as is. I'm going to go ahead and add 6 to both sides. Now if you wanted, you could write this separately as x equals 6 plus the square root of 3 and x equals 6 minus the square root of 3. I personally like to use that plus or minus symbol because it's quicker and more efficient, but I would accept either one. Onward to part 8, where we got to get rid of that times 2. So let's go ahead and divide by 2 on both sides, leaving us with the square of x minus 1 is equaling 5. Now we appear to be in business. To get rid of a square power, we're going to take the square root, as long as we do the same to both sides. A square power and a square root are inverse operations. They cancel out, leaving us with x minus 1 equals either the positive or its opposite of the square root of 5. Unfortunately, square root of 5 is not rational, so I'm going to just leave it as is. Now let's go ahead and add 1 to both sides. You may write it separately. I'm going to write it together, where we have a positive 1, either adding the square root of 5 or subtracting the square root of 5. Notice, because of that plus minus sign, I know we have two different solutions. One's going to be 1 plus 2 point something. One's going to be minus 2 point something. So we'll have a positive and negative solution in this case. Last but not least, we go on to number 9, where the first thing we'll do is subtract 3, leaving us with x plus 2 squared equals 0. I'm going to take the square root of both sides, and a square power and a square root will cancel out, leaving us with x plus 2 equals plus or minus. Now wait a second. Hold the phone. I can't help but notice that 0 is neither positive nor negative, which is interesting because while number 7 has 2 solutions and number 8 has 2 solutions, in this particular case, there is not a positive or a negative. So if I were to subtract 2 from both sides, we have one and only one number that you could substitute in here. Negative 2 plus 2 is 0. 0 squared is 0. 0 plus 3 equals 3. Shaboom. That's the only thing that's going to work here. If you're interested in Partner B's work, let me go ahead and draw a little boundary line. Notice, please, you'll have the same solutions for number 7, the same 2 solutions for number 8, but number 9, well, they're the same solution. There's only one of them. Pause if you need to, rewind if you want to watch it again. Pause, copy what you need, come on back when you're ready. All right, so we're going to take a look now at page 984. We're trying to solve the problem x minus 14 in parentheses squared equals 11. Now, Dury's got 14 plus or minus the square root of 11. Yosef's got 17.317 and 10.683. How are Dury and Yosef's solutions alike? Well, I do see 2 solutions for both. And if you went and typed this into your calculator, I'd be willing to bet they're the same. Or are they? Keep that in mind. Meanwhile, how are they different? Well, to be honest, Dury, I see, writes his solutions together using the plus or minus symbol. Meanwhile, Yosef writes the solutions separated. So I don't know if that's really that different. Now, let's take a look at checking their solutions. They both checked their first solution. Dury substituted his in. Yosef substituted his in. First of all, we're supposed to talk what happens in each step. So I can't help but notice that positive 14 and negative 14 cancels out. Now we take the square root of 11 times itself, which is kind of like the square root of 121, which is 11. Check. Now what happens in Yosef's steps? All right, so he substitutes his first solution in. He goes and subtracts it. Then goes to his calculator and types in 3.317 to the second power, and he gets that. Oh, now that's interesting. Checking out problem 12, Abina says, Dury's solutions are exact, Yosef's solutions are approximate. What does she mean by that? Well, I think it's pretty self-explanatory. Dury's solutions, when we substitute it in, boom, it is exactly, there's no argument, it's true. But Yosef, you could say, okay, look, man, those are really stinking close. Your answer is really stinking close, but it's not exactly the same or precise, I guess is a word we could say. All right, last page 985. Riku says, I also got Dury's solutions and kept going, but Riku made a mistake. How can we prove to Riku that he made this mistake? Now, people, take your brains all the way back to August. Do you remember that time? It was a long time ago. What would we do to prove if something is true or not? We would take a number, and we would substitute it in. And in this case, 5 minus 14 is negative 9. And I surely bet that negative 9 times itself is not equal to 11. I'm also willing to bet that if we put square root of 3 in, it might not work either. So if you're looking to prove to someone they've made a mistake, what do we know? 2 words, substitute, and then finally, check. All you got to do is put the numbers in and see if it works or not. Now, if anybody's looking for a super challenge, pause your video, see if you can work out 14, and come on back when you're ready. Not really going to talk through this, but I did find the solutions. I took one of them, and I substituted in. And if you want, pause and check, because it works. And so would the negative. That would work as well. Folks, that's all I got. I want you to either answer the prompt at the top or mark up some text. Notice we got 2 different possible solutions here. One equation actually has integer answers, the other does not. Now, of course, we can come up with approximate solutions, but we are always going to steer toward what are the exact solutions. Mathematics often cares about precision more than closeness. All right, guys, that's all I got for you. Take care, do well. Let's grow. We'll see you soon.